This video is for Chapter 12, Section 4, Part 1. There are two parts to Chapter 12, Section 4. One is about the angle measures caused by secants, chords, and tangents. The other is about segment lengths. We're going to first look at the angle measures formed by secants, chords, and tangents. Some of the things we've learned are that central angles share the same measure as their arc. Inscribed angles have a measure that is 1/2 the arc. So the next thing for us to look at is, well, what about angles that are neither central nor inscribed? They happen to land somewhere inside the circle. Here's a visual. Angle 1 is not a central angle. It's not on the center of the circle. It's also not inscribed because it's not on the circle. Angle 1 is vertical to angle 1 right here. So the problem is angle 1 seems to open up to angle or arc Y, but it also opens up to arc X due to the fact that those vertical angles are congruent to each other. So we can't say that angle 1 equals Y because that would mean that angle 1 equals X. And clearly X is bigger than Y. So now we have one angle opening to two arcs. For a central angle, it only opened up to one arc. For an inscribed angle, one arc. But now we have an angle that is opening up to two arcs that are different sizes. So we can go through and add a line here. This dotted line creates some inscribed angles. Now I see inscribed angle number 2 that is opening up to X. So therefore angle 2 is 1/2 of X. And angle 3 is opening up to Y. So angle 3 is 1/2 of Y. Let's put this up. Here's angle 2 is equal to 1/2 X, and angle 3 is equal to 1/2 Y. But there's one other fact. From our previous lesson, we remember the exterior angle theorem. Angle 1 is actually equal to angle 2 plus angle 3. Here's our triangle. 1 is an exterior angle. Angle 1 equals angle 2 and angle 3. But angle 2 is 1/2 of X, and angle 3 is 1/2 of Y. So let's substitute. Angle 1, the one we're looking for, is equal to 1/2 of X plus 1/2 of Y. Well, if we factor out the 1/2, we get the measure of angle 1 equals 1/2 of X plus Y. Now, interestingly, this is actually just saying that angle 1 is equal to the average between X and Y. Add them up, divide by 2. It's an average. Now, we're going to take a relationships quiz for this chapter. So what you're going to look at now is not only can we write angle 1 is equal to 1/2 of X plus Y, but we may want to write it this way. The measure of an interior angle is equal to 1/2 the large arc that it opens to plus the small arc that it opens to. Now, because addition, it doesn't matter if you write 8 plus 5 or 5 plus 8. It doesn't really matter what you put first, large arc or small arc. But for our next example, it is going to matter. So I like to put large arc first, no matter what. Measure of an interior angle, 1/2, large arc plus small arc. Okay, let's move on and go to what about angles that are outside the circle? So we're going to look at the exterior angles, and we're going to get a very similar relationship here. Here's an exterior angle. These two segments that we see now are not chords and they're not tangents. These are called secants. Secants are chords that keep going outside the circle. So I have two secants here that are forming an angle, angle 1, and this secant is opening up to one arc, two arcs. Opening up to two arcs again, notice one is larger than the other. But the problem is this angle 1 cannot possibly be the average of X and Y. The angle inside the circle would be, and that angle would be much larger than 1. Here we're pulling away, and the further we pull away, the smaller that angle is going to get. So let's try what we did on the last slide. Let's make a triangle with some inscribed angles. Now I see a couple relationships. Angle 2 equals angle 3 plus angle 1. There's our triangle relationship. Angle 3 is half of y, and angle 2 is half of x. There's our inscribed angle relationship. So, 1 plus 3 equals 2. Angle 1 plus angle 3 equals the measure of angle 2. So if I subtract 3, measure of angle 3 from both sides, I can say that measure of angle 1 is equal to the large angle, angle 2, minus 3. Angle 1 is angle 2 minus angle 3. Now substitution, because angle 2 is half x and angle 3 is half y. Substitute these in here and I get the measure of angle 1 is 1/2 x minus 1/2 y. Again, I can factor out the 1/2 and I have the measure of angle 1 is equal to 1/2 x minus y. This is not an average because it's not addition. It's 1/2 x minus y, which when we put in the idea, the concept, the measure of an exterior angle is equal to 1/2 large arc minus small arc. Large minus small is very important because if you do small minus large, you're going to get a negative number, which is impossible. It must always be 1/2 large arc minus small arc. Now, there are 3 different versions of exterior angles. You just saw one and saw it as an exterior angle. It looked like this. That's when it's formed with 2 secants. But an exterior angle can be formed with 1 secant and 1 tangent. Still, large arc and a small arc. It can also be formed with 2 tangents, which is the most unique one when we do our examples, because there are 2 arcs, large arc, small arc, but those 2 arcs together must add up to 360 degrees because they are the whole circle. All 3 of these pictures have the exact same relationship. 1/2 large arc minus small arc. When we take the relationship quiz for chapter 12, this will be 3 different problems. They all have the exact same relationship, but you'll be asked to identify the relationship between 2 secants, secant tangent, 2 tangents. They all come out the same. The measure of the exterior angle is equal to 1/2 large arc minus small arc. We will do some examples of these in class where we're just plugging numbers in, but that's it for chapter 12, section 4, part 1.